All right, here we are at the top of page 4 for section 4.1, and the book on page 228 kind of summarizes what we've been doing. So if you need kind of a verbal walkthrough of what we've been doing, then you can look at page 228 for this little helpful chart. And let's continue on. They're going to continue this. You see we're at number 80 for the example. This whole section is just about learning to graph the line, and we're doing it by finding at least 5 solutions. So we're doing the table method here. So as we start this, as we look at number 80, I want you to always be aware of that question, what's different? As you look at something and go, I'm not sure what to do, before you panic or try to make up new math or get frustrated, just ask yourself, why is this causing me to hesitate? What is so different about this one than the ones I've seen before? So number 80 says y equals 3. Well, what's different about this? Well, previously we have seen, what we're used to is seeing something in the form of y equals mx plus b, something times x plus b. Well, what's different is it feels like the x piece is missing. And so the reason why I want to do this one as an example in the notes is because I want to be able to help you kind of get over that and help you see what's going on here. And what's missing is the x piece. So there's no x piece here. Well, how does that go away? Well, it goes away if it gets multiplied by 0. Okay, so what we're really looking at is y is equal to 0 times x plus 3. That gives us that same version of y equals 3. Now I'm just going to take a little side note here before we work on creating our table, our sets of x, y here. And the side note is this. Here is our motivation for why we have been practicing set notation. Okay, why we've been putting our answers into little braces instead of saying y equals or x equals or whatever, is because of this right here. This is actually a way to describe a linear equation. This is an equation that can be graphed. This represents a line, an entire set of solutions. So that's why we have now introduced set notation, so that when we're just talking about a single answer, y equals 3 or something like that, then we can do that by using the set notation, the braces. But when we're talking about a line, we can go ahead and describe that using x or y. So let me show you what I mean by that. Now that we've gotten over the little hesitation of what's so different about this, oh, it's missing x piece. It's like it's y equals 0 times x plus 3. Okay, and that would just give us 0 for that spot, y equals 3. We can still pick our x values. We want to pick 2 negatives, 0, and a positive. I don't see any fractions involved, so I'm just going to pick my standard set of -2, -1, 0, 1, and 2. And then when you plug that in, when you take that y equals 0x plus 3, or just y equals 3, no matter what you put in for x, it's going to get multiplied by 0. There is no place to put x. No matter what you put in for x, it's going to get multiplied by that 0 because that x piece doesn't exist. It fell out a long time ago. So no matter what you put in, you're going to get 0 in that spot. You could put in all kinds of things. You could put in 17,000. You could put in -3.6. No matter what you put in, it's going to get multiplied by 0, and then 3 will get added to that result. So when that happens, you put in -2. Well, you just put in -2. There is no place to put in -2. You're always just going to end up saying the same thing, y equals 3. Well, what you're really doing is you're putting in -2, multiplying it by 0, and then adding 3 to it. But you always get 3 as your result. you put in -1, it's being multiplied by 0, or think of it as there is no place to put in an x, so I just get 3 as my result. My y value is always 3. I try putting in 0, there is no place to put it in, or imagine it being multiplied by 0. Your result is 3. Your result is 3. Your result is 3. And 3 again. And it's 3. Okay? What this equation is saying is y is always 3. No matter what you put in for x. Okay. Well, what does that mean graphically? Well, if here's our axes, here's your x-axis, positive and negative. Here's our y-axis, positive and negative. We can plot these points. Here's our first one, -2, 3. So -2 to the left and up 3. There it is, -2, 3. And then our next point is -1, 3. There it is, -1, 3. And then our next point is 0, 3. 0, 3. And our next point, 1, 3. Over 1, up 3, there's our next point, 1, 3. And our next point that we tried, 2, 3. And then we tried way off the charts, over at 17,000, way up here, and we still landed at 3. Or we tried -3, just past the halfway mark at -3.6, and still got 3 as our y value, okay? So no matter what, when you connect the dots here, you get a line. You get a special kind of line. You get a horizontal line, meaning it runs across the horizon. Okay, like across the sunset here, left, right, horizontal. You get a horizontal line. So the question I want to pose to you is if y equals a number, is really saying that y is always 3 no matter what you put in for x. You can go anywhere on this x-axis and stop and plug it in, and you'll always end up at that y value. And then when you connect those dots, y equals some number will always give you a horizontal line. Y equals some number is always a horizontal line. And you can either memorize that, or you can always go back to create a quick table and convince yourself that it connects the dots to be horizontal. So then make that little conclusion jump with me. If y equals a number, we'll create the same number for the y value every time, and no matter where you go on the x-axis for your first coordinate, you jump up to that y value and it connects the dots to make a horizontal line. What would be created if you start with x equals some sort of number, like x equals -4? What would happen then? And that's something we'll talk about in class, but see if you can imagine what would happen if x is a number. For example, x is -4. We'll talk about this in class. Okay? Alright, I'll see you at the bottom of the page for a practice plus problem that you get to try.